Welcome to Chemistry Simplified. Our topic for today is how to balance chemical equations. This is a very important topic in chemistry. Unless you can balance equation, it will be very hard for you to work out stoichiometric problems. So let's get started. So let's look at the steps that we need to know in order to balance chemical equations. Step number one, you need to write a correct formula for both reactants, which normally are on the left, and products, which are normally on the right side of the equation. Number two, should count the number of atoms of each element in the reactants and products. Step three, if anything is not balanced, you should use coefficients, not subscripts, to balance them. Step number four, you should always check the final equation to make sure that each type of atom is balanced on both sides of the equation. All right, so these are the basic steps we're going to be following in order to balance these chemical equations. We have a few examples to do. Let's get started. Example number one. Let's say you are given potassium chlorate, which break down to give potassium chloride plus oxygen. Oxygen exists as a diatomic O2. So potassium chlorate would be our reactant, and potassium chloride and oxygen would be our products. Potassium and chlorine are balanced so far, right? Because we have one potassium on the left, one potassium on the right side of the equation, chlorine, one chlorine on the left, one chlorine on the right as well, right? So one potassium on each side of the equation and one chlorine. So far they are balanced. However, we have three oxygen on the left and two oxygen atoms on the right, so oxygen is not balanced. Right, so three oxygen, and on the right we have two oxygen, so therefore we need to balance oxygen. In order to balance oxygen, we would place a 2 in front of potassium chlorate on the left side of the equation, and then a 3 in front of oxygen, which is on the right. Right, so 2 for potassium chlorate and 3 for oxygen. Remember, we use coefficients, not subscripts. So now oxygen is balanced because we have 2 times 3, 6 oxygen on the reactant side, and we have 3 times 2, 6 oxygen on the product side. Now, because we place a 2 in front of potassium chlorate, now potassium and chlorine are no longer balanced. So we need to adjust that. So we should place a 2 in front of potassium chloride on the right side of the equation so we can balance everything out. So there it is. We place a 2 in front of potassium chloride. So now everything should be balanced. Let's check the answer. Right, so we have reactants and products. So we have 2 chlorine. Right? Chlorine is balanced. Oxygen is balanced. So everything is balanced. So therefore, our equation is fully balanced. Now let's look at example number 2. So let's say nitrogen react with hydrogen to produce ammonia. So this equation is not balanced at all. Why? Because we have 2 nitrogen on the left side and only 1 nitrogen on the right, 2 hydrogen on the left and 3 hydrogen on the right. So we need to place a 2 in front of the ammonia in order to balance it out. That's what we do. So now nitrogen is balanced, but hydrogen is not balanced. Why we say that? Because we have 2 hydrogen on the left side of the equation, but we have 6 hydrogen on the right side. Right? 2 times 3, that's 6 hydrogen. So we need to place a 3 in front of the hydrogen on the left to make it 6 as well. Now everything should be balanced, so let's check. We have 2 nitrogen on the reactant side, 2 nitrogen on the product side, 6 hydrogen on the reactant side, 6 hydrogen on the product side. So our equation is balanced.